again. So the first definition is bisect. So bisect divides into two equal parts. So you could bisect a line segment, or you could bisect an angle. So let's say we bisect an angle. So this line in the middle bisects the bigger angle, which means that we have two equal angles. All right? So if it says something bisects, we have to state that, and then we can state that this angle is equal to this angle by definition of bisect. Okay. And then we have a little review of parallel lines. So these two lines are parallel, cut by a transversal. And let's say I label these 1, 2, 3, 4, 5, 6, 7, 8. So alternate interior angles are inside the parallel lines. So raise your hand if you could give me a pair of alternate interior angles, Pete. 5 and 4. Very good. 5 and 4, thank you. And 3 and 6. So we've got 5 and 4, 3 and 6. Okay. Then we have alternate exterior angles, which are on the outside of the parallel line. Somebody besides Pete? You can. Yeah, I think so. But you maybe forgot. So, Alex, what else? What's exterior angles? Good. Okay, 1 and 8. Sarah? 2 and 7. Okay, then we have corresponding angles. There are 4 sets of them. They have to be in the same place on each group of 4. So anybody who hasn't participated yet, remember and can give me a set of corresponding angles. Thanks, John. So 1 and 5 are corresponding. Okay, what else? 3 and 7 are corresponding. What else? Good. 2 and 6. And the last one would be 4 and 8. Okay. All right, so I always use alternate interior angles, alternate exterior angles, and corresponding angles for my reasons when I'm stating why, okay? All right, you guys, go ahead and draw this picture, and then we'll prove why PQ is congruent to SR. All right, so Verada, what should I write down first? Okay. And our reason is given. And Alan, what should I write down next? Yeah, what does this mean? Good. Okay. So we're going to mark the givens on our picture. So I have angle Q here is congruent to angle S. And then to mark parallel lines, so PQ is parallel to SR, we use this arrowhead. Okay, Kaylee, what else do we know from the picture? Yep. Oh, and we're back. Okay, so PR is congruent to PR, reflexive property. So let's mark that side congruent. All right, so we have parallel lines. So this line right here is parallel to this line right here, and this would be cut by a transversal if you extended them. So it's kind of easier to see if you extend them a little bit. Then we can find some congruent angles probably. So anybody who has not participated yet, can you tell me congruent angles? Where they are based on the parallel lines, Liam? S and Q. We already marked those because of given.
R and P.
Okay, but we have to say where on R, right? This one's not it, but this one is. So we've got this guy here, congruent to that there. So for side, or for angle 4, we would say QPR, angle QPR, is congruent to angle PRS. And that would be by what? Sarah? Good. Okay. They're inside those parallel lines, alternate interior angles. All right. So we have a side and 2 angles. So Zeb, what else can we say is equal here? Not sure. Ethan, what do you think? Good. So we know 2 angles, we know 3 angles. So angle QRP is congruent to RPS. Because if we know 2, we know 3. All right. Yes. All right, Ryan, now what can we say? Not yet. Before we state this is the final thing. We have to state that the triangles are congruent. Okay, and we have to go in the same order. So if I say PQR, we have to match it up with the same angles on the other side. So PQR is this, this, this. Then what triangle do I have to say on the other side? RSP. And my reason, Tom, that we know these triangles are congruent. Okay, angle, 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 side. Now we can state the final thing that we were trying to prove, which is PQ is congruent to SR by, okay, what's that stand for? All right, good. Good. All right, let's do one that has bisect, definition of bisect in it. So go ahead and draw that picture. And Danielle, what should I state first? Good. Good. Okay, Wyatt, what should I state next? Okay. So go ahead and mark angle ABC congruent to angle ADC. And then AC bisects BAD. So because it bisects, what can we mark? Right. So this bisects this whole angle here. So BAC is congruent to, so angle BAC is congruent to angle CAB. And what's our reason? Yep. Definition of bisect. All right, so by looking at the picture, we can say, Sebastian, what else? Good. Good. Angle ACD, so this guy right here is congruent to angle ACB. We know 2 angles, so we know 3 angles. And Kayla, what else do we know by looking at the picture? Very good. And we can go ahead and mark that congruent. So Tom, now what do we know? Okay, good. We know that the triangles are congruent by angle, 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 side. So we have to say them in the right order. So if I say A, C, B, so if I go A, C, B on the top triangle, what would the next one be? Good. All right, so we stated that they are congruent. Once we have congruent triangles, we have congruent parts. So BC is congruent to DC. ICPCT.